I've written 4 number sequences on the board here, and what we want to do is find the next term in each sequence. The reasoning process that we use when we find the next term in a sequence of numbers is called inductive reasoning. We look for a pattern in the first few numbers and then see if we can continue that pattern. Our first sequence here is 1, 8, 15, 22. Now, the first thing I do is look to see if subtracting 2 consecutive terms in the sequence always gives me the same number. In this case, it does. 1 plus 7 is 8, 8 plus 7 is 15, 15 plus 7 is 22, so if I add 7 on again, I'm going to get the next number in the sequence, which will be 29. Now, when we have a sequence in which each term comes from the previous term by adding the same number each time, that's called an arithmetic sequence. Here's our next one. 1, 8, 64, 512. So here I have, let's see, if I look at this, I can't add the same number and progress down this sequence. Let's look at multiplication. 8 times 1 gives me 8, so if I multiply here by 8, I get this term. Now 8 times 8 gives me 64, so again I multiply by 8. 8 times 64, 8 times 4 is 32, 8 times 6 is 48, and 3 is 51, so again, multiplying by 8 gives me this term. So I'll multiply by 8 again and get 8 times 2 is 16, 8 and 1 is 9, and 8 times 5 is 40. 4096 will be the next term in this sequence, and this sequence is called the geometric sequence because each term comes from the previous term by multiplying by the same amount each time. Our next one, 1, 8, 27, 64. If I add 7, I get this. If I add 7, I don't get this. Multiply by 8, I get that. Multiply by 8 again, I don't get that. So I'm going to have to look for something else. How about, let's see, 1 to the 3rd power, 8 is 2 to the 3rd power, 27 is 3 to the 3rd power, and 64 is 4 to the 3rd power. So I have a sequence of powers of 3 where the base increases by 1 each time. So I'm going to guess that the next number in this sequence will be 5 to the 3rd, which is 125. So this sequence is not an arithmetic sequence or a geometric sequence. It's this sequence right here of powers of 3. So 1, 2, 3, 4, 5 for the base, and then the exponent is 3 in each case. So the next term in that sequence will be 125. This sequence here I have, again, it starts with 1, then 8, then 16, then 25. So it looks like maybe I could add 8, but then when I add 8 to 16, I don't get 25. So let's look at addition again. No, that wouldn't have worked anyways. 1 plus 7 is 8. 8 plus 8 is 16. 16 plus 9 gives me 25. So how about if I just add on 10? Now that I've noticed this pattern right here, 25 plus 10 is 35 for the next number in that sequence. So some sequences, like this one right here, I don't see any particular pattern that involves exponents or anything else. I'll simply look and see if I can find any kind of pattern whatsoever in which to continue that sequence. And here I added consecutively larger integers each time, so I'm going to say that the next number in that sequence is 35. That process that we use of reasoning to find the next number in each one of these sequences, that's called inductive reasoning.